Hello everyone. In the previous video, we have created some of the layers, some of the geometries using Google Earth Engine, and in this video, I'm gonna tell you about other Java basics that we can do in Google Earth Engine. So let's get started. In the previous video, we have created a circle, a rectangle, and uses the US states and dissolve them, some of like that functions. Now let's create other functions that we can use in Google Earth Engine. So first of all, we will create a bound. So the small rectangle that fits the entire geometry, that is called as a bound. So let's comment here bounds, and now let's generate. First, we will define a variable named as bound, and this uh, we will use this layer to make the bounds. So dot geometry, and for bounds, we use the bounds function 100, semicolon, enter. Now we just add it to the map dot add layer, and we want bounds to add in the map. Now we define some of the colors in the curly bracket. Color, it's pollen, and I want yellow color for this. Plus, I have to rename this as bounds. Now let's run it and see that bounds are added in the map. Okay, so this is the bound that have added into the map. Okay, so next create um, a convex hull. So what actually is the convex hull? It's the smallest polygon that wraps around all the extremities. So let's create a variable for this convex. We again use this. So I just paste it dot geometry and dot. I am not gonna use their count. I'll use convex hull. So again 100, and again adding to the map. I will use the same code. Just rename this and rename this. Let's run it and see. Okay, so this is the smallest polygon that wraps around all the extremities. This is the difference between a bounce and this is convex. Okay, so now let's create the intersection, the union, and the difference, like how intersection, union, and these type of uh, analysis, spatial analysis work in Google Earth Engine. So let's first work in intersection. So for intersection, we will first create a variable named as an intersect, and I will create this intersection over convex. I'll use convex layer dot intersection. I want it as a circle and 100. Now just add the map to the layer. Map dot add layer, intersect, and let's define its color. I want it as green, and now just rename it as a intersection. Okay, it's giving me error there. Okay, so we have intersection layer, and this is the intersection layer. So this is how intersection works, like the overlapping areas between two geometries of the convex. So for now, let's create union. Let's comment union, and union is everything covering by every geometry, either geometry that we're gonna use. So first of all, let's create a variable that is union, and I'm again use convex dot union circle, and just adding it to the map dot add layer, union, defining color, uh, let's say it is a pink, and rename it as union. Now run it, and let's see how unions look like. Okay, so this is how union is look like. Uh, it covered everything of the entire geometry. Okay, so now let's see how a difference function works. Okay, so the difference function is actually what is in the geometry, what is in the one geometry, and but not in the other. So the first one, we will see just the first one. So var diff is equals to, we will apply this in convex dot difference circle, and again 100, just adding into the map, defining the color, let's make it black, and rename it as difference. Now let's run and see how it looks like. Okay, so now this is the difference that is in the first layer but not in the second layer. So after practicing these, I think after all of that practice, we're gonna type map.add layer. You can uh, add any layer in the map, you can define the color, you can rename it, you can define a variable, you can do some of the spatial analysis that we have done. So finally, now we can calculate the statistics. So let's calculate some statistics, like how it's going to work in Google Earth Engine. So first, I will create a variable r, and I use this variable over here, dot geometry area 100 print. Okay, let's run and see. This is the number over here is the area, and it's in meters. Now let's calculate perimeter. var Harry. I will again use the same variable. So let's run and see its parameter. Okay, so now this is the parameter. This is how statistics work in Google Earth Engine. Now look at all those layers on the map. Each color represents a different spatial relationship. This is the foundation of spatial analysis. So now I think the foundation is clear. Now let's move to the next topic, that is features and feature collection. Now let's talk about features and feature collection. So a geometry is just a shape, but a feature is a shape. Let's information about it. Properties of that feature. Like think of a feature like a row in a spreadsheet. The geometry is the location and the properties are the column. Name, uh, population, temperature, whatever you need. So here's how you create one from the scratch. So let's get started and create a variable name as a word geometry. Let's create a geometry dot. We first create polygon, and we have to give polygon some of the numbers. Let's give it 30, 20, 0 and 0. Okay. So now let's create another variable, that is var feature, and that var feature is equals to pe dot. Okay, so here is a cross because we need to make it e it's case sensitive, so we have to make it uh, greater. Feature there, feature. We will define some of its properties over here. So its first property is we will call its name, and name is in the square bracket, and let's rename its feature name. And now we can say that feature name is, for example, supreme, and then bracket close, comma, and now we define its size. So its size, we will define it again in the square bracket from 500 and 1000. Okay, so now here's the black bracket open, and now let's close the bracket, and in the semicolon. Now okay, so you can extract a specific property from this. Like if I want size, what I will get is var array is equals to var from var feature. Like in from this layer, I want to get size, I want size, and print. Now if we run, okay, so now we have the size of the feature. By using this we can extract other information like that for the feature. And what about feature collection? Feature collection is just a group of features, like a whole spreadsheet or a shapefile. The US counties dataset that we used earlier, that's a feature collection with the thousands of features in it. So that's how we talk about features and feature collection. Let's talk about how filters work in Google Earth Engine. So first, filters are how you narrow down data, like whether it's a feature in a collection or image in a dataset. So first of all, let's use the equality filter. Uh, let's first define the variable b filter, and we're gonna use dot filter for filtering dot eq. Now here the eq is equal to, and inside you're gonna use a lot of things if you wanna use. So the basic function over here is equal. We have another function that is dot n eq. It's mean not equal. We have another function that is dot lt, less than. We have another function that is dot glt, like it's greater than. So these are some of the equality filters or other filters that we're going to use. These are the most important that we're going to use in our coding. So this is how filters work. We also have text filters, we also have other filters. We can also combine the filters, like a simple formula of adding them. So this is how filters work. Okay, so we have talked about the filters. Now let's talk about the one of the most important powerful pattern in Earth Engine is mapping a function over a collection. Like we are not collecting the images, we're just passing a function, and instead of writing a loop for every image which is low, you define a function and apply it to every element in the collection in parallel. Earth Engine handles the distribution across Google server. So here's the basic structure. First, we define the function. So let's define a function. Let's get a practical example of this about using the US counties that we have already used. So let's first define a function, perform map, and pass the argument feature. Okay, so inside it, I'm gonna say that war define a variable that uh, simplify the feature up to 1000, up to 10,000. Then define another variable that make a center, and that is simple dot centroid, and then I will say it return center dot buffer, and the size of the buffer is 5000, semicolon, and this is how I define the function. Now my function is defined and its name is a perform map. Now I call this function in every where I wanna want in this code. So let's define another variable that is mapped centroid, and use the county connect layer. and I call the function perform map. Next, I will add this to the layer. Then you can see how it works. Then define the colors. Like I want it in red, and then we can have a name map of Forbes Centroid. So let's run it and see. We are having error here. We have used as a buffer, not buffer, so it's buffer. Okay, so now we have the final layer, and we have buffers. We wrote the function once. Earth Engine applied it to all the 8 counties simultaneously. Imagine doing these thousands of features across the entire planet. That's why Earth Engine is powerful. That's why we use Earth Engine. So these were all the basics that we have talked about. So now let's talk about the real imagery that we're going to use in Google Earth Engine. Now we get the heat of the Earth Engine working with the actual satellite imagery. So what is an image? Image in the Earth Engine is a raster, a grid of pixel values with one or more bands. Or what is image collection? It's a time series of the images, like every Landsat scene ever captured over your study area. So let's load the MODIS data, MODIS land surface temperature data, and analyze it over the same study area. MODIS LST. So first we will centralize our map to the center. And we're going to define the longitudes and the latitudes. And the zoom level is 8. Semicolon and run to see if any error. Okay, it's zooming. Okay, so now we create a variable and we will define our image here. So let's search here MODIS LST. So we have a lot of data sets for MODIS. We can use any one of them. I'm gonna use this one. So just copy its snippet, and you can see bands here. We have only one band, that is LST day 1 kilometers. We have also other bands. We're going to use only this band. We have terms of use, citations, descriptions, and everything. Let's use it. Just close it and use it here. So this is how we're going to use imageries of the uh, datasets. So print it to see what's inside the JavaScript. So we print raw, run. Here is the image collection that we have just printed. So we have image collection, this, we have this model, we have this version, features, its properties, we have these, we have in total 12 10 images, we have system properties, we have everything. So now let's filter the date. For this, create a variable filtered. uh, I'm saying it that go to the raw, and inside raw go to this image collection, and what to do filter date. And what's the date exactly? I want 2000 to 12:30. And what's the ending date? That is 2004 27. So that's how it filtered the date. I'm saying it that go to the raw, and inside these images filter the date for only these dates, and remove others, semicolon, and it will just make the filter. So now let's calculate the mean across all the images, pixel by pixel. So we'll calculate mean now. Let's make a variable named as mean, and we use the function band cell 1 dot mean, semicolon. Now we just clip to our study area only, and for that we'll create a variable. We will just create the region of interest, county data dot filter, that is equals to, we will select only one state. Okay, we're gonna use this over here, and state is 09, semicolon, and enter. And now we create a variable as a clipped. Clip to my region of interest. Let's run it. Okay, so now we have just clipped to our study area. So now clipped it. Now convert from the raw satellite digital. Now convert from the raw satellite digital number to degrees Celsius. So for that, we will define another variable, that is calculate, and I name this as a clip dot multiply 0.02 dot subtract 273.15. We use simple formulas in a line as we use in a calculator, which is JavaScript is so easy, it understands the easy language. So we're just gonna define it, and it will do. So and display now it with a color palette, blue for cold and red for the hot. So let's add to the map dot add layer, and for that we have to calculate what another function, that is the minimum value, which is 15, and the maximum value, that is 20. Now I will define a palette over here, and the palette I will use square brackets, blue, green, and red. I'm going to use. So we have defined everything. Now I'm going to say just close, and let's run. So you can get this type of error, like we can uh, make it. We will just open our dataset that we have used. Just copy this from here, close, close, and paste it there. Now let's run, and let's see we have the image collection or not. Okay, so this is how Modis LST works. It's the reddish area have are the hotter, the greenish area are the greenish areas are less hotter, and that blue areas are more or less hotter. So this is how LST of the Modis work. So uh, if you mask it to the to some degrees, like 18 degrees, you can also do this. uh, a mask work like a filter for the pixels. We create a binary image where 1 means keep these pixels and 0 means hide it. That's how it's work. So let's create a mask for the temperature that is below than 18 degrees C. For mask, we will create a mask function variable. We will create a mask variable, and after equal, we will say calculate dot greater than 18. We will create another variable named it as a mask. Update mask, mask, and now we add this map to the layer. And now we will define also some colors. We will just copy these colors and just paste it. Inside it, we have a minimum value, we have a maximum value, we have a palette, and then we have a close bracket, a curly bracket, and semicolon, and run. So these are the places where temperature is greater than 18 degrees. We can also mask like that. So this is how mask works, like filter for the pixels. We create a binary image where we have given it two values. One means keep that pixel, and 0 means don't keep that pixel. So this is how mask function work in Google Earth Engine. One of the most important tasks to do in Google Earth Engine is exporting the images and their file formats. So let's get work on it. Exporting. So first of all, I will talk about how we can export an image to the Google Drive. So for that, we use a function export dot image dot to drive, and then we have some of the important things like we have collection. Here it comes war image, like the image that you wanna export. Then we have a description for that, like description. uh, it's the file name actually that we're gonna write inside there. We have another important uh, factor, that is region. And region is the region of interest, like the shapefile that we're gonna work on it, or maybe that we have worked on it in the code. And the last thing is scale. Scale depend on dataset resolution. Like for example, I have used the modis, and LST modis have the resolution of, so we're gonna use it as 1,000. So this is how export function work in Google Earth Engine. Semicolon and just run. You will get your image in the exports. Now we can also export the images as CSV. Like we have different formats. We can also export it in the Excel. So let's talk about how we can export our data as a CSV. So first of all, we will again define export, same as that of here, but here we want it as a table. And then I have to say it to drive. Then I have some properties for that. And what are they? They're like first collection, and collection is my feature collection from the code. And you have to again define the description. Okay, the description is output file. It could be any name that you want to give it. And then finally we have a file format, that is CSV. And semicolon, and you can run. Now we have studied two type of exports. The first one is image, and the second one is CSV. We have a lot of other formats in Google Earth Engine too. When you run an export, it appears under the task tab here in the code editor on the right panel. You have to click run to actually start the export. Don't forget this step. uh, it won't run automatically, so you have to run it and you have to save.